board. Kaboom. All right. So we've looked at if statements and else statements, and we've seen that they allow two-way branching, right? If will work if you just want something to happen if the condition is true. If else provides options if the condition is true or the condition is false, right? But it's a two-way split. Now, if you have a lot more than two options, it can start getting really hairy really fast as far as what direction the code is going to go. So Java has helpfully provided something called a switch statement. And the switch statement allows you to branch off from a bunch of different points. It's nothing that you couldn't replicate with a bunch of ifs, but it's a lot more intuitive. You can just look at it and see everything right there. So let's give an example. Let's drop out of this and go into our Eclipse. And we're going to make fun with switches. Fun with switch is just fun with switch. We'll just have one. So imagine we have a student, and the student has some grades. Okay, so we're going to call up a method here. We'll make it. Let's code in a method. We'll say string. It's going to return a string. We'll say get feedback will be our stuff. Okay, and we'll send in a set of grades. Okay, so int t1, int t2, int t3. So the system's going to look at this and say, how did you do on these exams? Okay, so we're going to process it this way. I'm going to say fun with switch. I don't know what happened there. FWS is new fun with switch. Okay, we're going to give it, we're going to call this method. Let's suppose our test scores, right? Suppose we read the test scores from some outside source, right? We're pulling them from some database somewhere. And we call this method, okay, system.out.println get fws.get feedback. And we'll send in the three numbers, right? So we'll say 80 and 75 and 95. And those will be the three tests. Now, in our get feedback method, we're going to have a switch option. Okay, so this switch, if we wanted to do something, suppose our cutoffs are 240 to do well, whatever that means, okay? 180 to pass, less than 180, fail. Okay, so we have some messages we might give around that. So we're going to process these things. We're going to say if, yeah, this will work. I guess it's fine. T1 plus T2 plus T3 is greater than 240, greater than or equal to 240. Return, you're doing great. Okay. Else, if T1 plus T2 plus T3 is greater than or equal to 180, return, you're doing okay, but do better. Okay. And then the last one, else if T1 plus T2 plus T3 greater than or equal to 0, I guess, return, you are in danger of failing. Okay, and then the last, return system error, negative grade, negative points. Okay, so I did the stuff here wrong. Let's get those cleared up. Okay, so this makes sense in terms of ifs and elses, right? We can look at this and say, okay, yeah, this is fine. Now, if we total up the math, 155, 250, that's good. When we run this, it should print out, you're doing great, right? We're going to call this method, send along the 3 values, get that kind of feedback. You're doing great, hooray. Okay, on the other hand, if one of them is a 0, then the student's going to be failing. The total is 170. So we could run that, save it, boom. You are in danger of failing, oh no. All right, so that's what we've got in terms of ifs. Now, in a switch statement, right, a switch can replicate anything that's in an if can replicate anything that's in a switch statement. So we could do the same thing. So string get feedback 2. Okay, we'll send in this int t1, int t2, int t3. Okay. Now, if we wanted to do a switch statement, this kind of situation would not translate well. Okay, so what we might do is total, int total equals t1 plus t2 plus t3. Okay, and we could do a switch on total, but the problem is the switch is only going to switch on exact values. Okay, so switch will require exact values. Now I'm going to indicate how this will go through. So first of all, let's get a string message. Okay, down here I'm going to say return message. Okay, we still have an error down there because we haven't initialized it yet. Okay, so I'm going to set it initially to this. Okay, the system error thing. In this case, if we have some exact values, we could do something like case 240 return message equals you're doing great. Okay, case 180 message equals this. I'll lift that. Okay, and then this one, case 0 message equals this, and then return the message. Okay, so let's try this. We're going to do get feedback here with this one, and then get feedback 2 with the other, and we'll get a little bit of insight into what's happening. Okay, so I'm sending along the same arguments to the same to the 2 different methods here. Let's run it. See, in this one we're doing great. Why? Because we used ifs and we did this. Our switch requires correct numbers. So we got this system error. Let me walk through. So our total here, that's 170, that's 250. Okay, so what happened in our switch block, we have the switch, we consider the value total. We say, okay, what's total? It's 250. Well, we have these cases. The cases show the entry points into the switch block. So if we match one exactly, we'll go through with that. Okay, so case 240 gives that, case 180 gives that, case 0 gives that. Now, these cases on the side, they're all entry points. So I can do case 250, case 245, case 240. Since I've set up multiple entry points here, they're all going to go through to this point. Okay, so if I run it again, it did that. You're in danger of failing. Why? Because we didn't go out. So I got to do a break statement here. Do a break and a break and a break. Okay. So run it one more time and I'll walk through the process of this. Okay, now we get doing great on both of them. So since we have an exact value in our case here, right? Again, these cases are the entry points to the switch block. It says, okay, case 250 assigns a new value to the message, hits a break statement, which pops it out of the switch block. Okay, so it stops looking at stuff in the switch block. Without that break statement, we had what happened before, where the path kept rolling along. It went through the message equals this, the message equals this. Okay, and then it popped out at the end with return message, but our message was the last one that got assigned, you're in danger of failing. So the way we did it second time around, we had a correct entry point. After we got the result we wanted, we did a break to get out of the switch block, and then we returned our message, which said, you're doing great. Okay, so that was the quick intro to switches, how they work. So the thing is, you have some value that you're switching on, right? So it could be an int, or it could be a string, could be an int or a string are the common ones. And then you switch based on that. Okay, so depending on where you find the exact match, yeah, that's what you get. Okay, it switches you to a particular bit of code inside the switch block. So for this particular example, since we have a wide range, I'll say, since there are a wide range of possibilities for the switch, if statements are probably better, probably much better than switch. Okay, but let's go back to the slides. We'll see an example where the switch is actually, you know, pretty appropriate. Okay, so we'll do the syntax in a moment. So in this case, we have the example, credits equals student.credits. So we read the student's credits from some outside source. We initially set our string s to read problem. Then we do a switch on credits divided by 30. So remember, integer math, if we take this credits value divided by 30, any fraction gets dropped. So if we can reduce our set of credit options to a set of simple cases, right? So case 0 equals freshman, case 1 equals sophomore, right? 0 to 29 credits freshman, 30 to 59 credits is sophomore, 60 to 89 credits is a junior, or case 3, 90 to 119 credits, you get senior, okay? Now in this case, if credits are 91, so we go through, we read credits, it's 91, we assign S the text problem, we do a switch, 91 divided by 30, that reduces to 3, and nobody cares what the decimal part is because it gets dropped. So we go to the case, right, the appropriate case for that switch value, case 3, we assign S the value senior, and then we break to get out. But if credits are only 1, then what happens is this. We take switch on credits divided by 30, so we switch on 0. We hit case 0 as our entry point. We go in there. But since we don't see a break, we continue doing these other statements. We continue with S equals sophomore, S equals junior, S equals senior. And at the end, S will be senior. So you need the breaks at each one of those. All right, so the key syntactic elements here. Number 1, you're switching on some value. For every value that you're interested in, you set up a case for that. And the case is just the entry point into the switch block. It doesn't indicate anything else. And if necessary, if you don't want other things to happen, if you want all of these, this case 0 to be modular, for example, and be separate from the other cases, then you just put a break afterwards. So once it executes this S equals freshman statement, if there's a break, it pops out of there. Okay, so let's go back to the our Eclipse example. So the way I've done this, it's not that great, right? If I'm setting up the code this way, well, we're going to set it up in a way where it is a little bit useful. We'll do string get grade, okay? And we'll assume there's a smooth scale. So int T1, T2, int T2, int T3. Okay, and we'll divide it by 10. Okay, we'll convert it. There's a 10-point scale, let's say. So each of these, say each grade between 0 and 100. So we'll say int percent equals T1 plus T2 plus T3 divided by 30. Okay, so divided by, yeah, that's right. Okay, that's good, divided by 30. So we'll implement our 10-point scale. Now, within our switch block, we can switch on that. You know what, we can even do, let's do decile. That's a better word. That's really what it is. Okay, it's a group of 10. So we'll switch on the decile. And we'll say case 10, the message will be perfect, 100%. Okay, case 9 we'll list as an A. Case 8 we'll list as a B. Case 7 we'll list as a C. Case 6 we'll list as a D. Case 5, oh, we need a string too. So string message equals nothing. Okay, so here we'll do message equals. Okay, case 5, message equals F. Okay, now for this case, there's a bunch of other cases. So we can do this case 4, case 3, case 2, case 1. Okay, we'll do that, message F, and then for case 0, we can write a custom message, message equals you have no points. Okay, and then at the end, we'll return message. Okay, so for this, let's make it system error, improper point total, right? Could be negative, could be too high, whatever. So in this case, we can look at this switch block and we see very clearly, okay, yeah, 10, 9, 7, 6, fine. Right, we have a list of sensible values. So I can call getGrade. Let's do this. We'll do the same 3. Okay, we'll see what it says. You have no points. All right, something went wrong there. Must have done some math wrong. Oh yeah, the breaks again, duh. Okay. This is not my best day. Okay, so we got all those breaks, fine. Okay, let's run that again. Boom, we got our B. Okay, so we take our point total, we do 80 plus 75, 155, 250. When we do this, when we get 250 divided by 30, well, 240 divided by 30 would be 8. So we're in the 8 range. So we enter in at case B, case 8 there. Our message is B for our grade, and then we break. We're done. Okay, so for cases like this, if you want to compare to how it would look, you know, in a set of if statements, it would look something like if decile equals 10, you know, message equals blah, else if decile equals 9, message equals else if decile. You get the idea, right? There is potentially more stuff in here. These ifs, these elses. It's easy to miss an else. It's easy to somehow have your code be a little bit off. But with a switch, right, you don't have to worry about entering in all those if and else statements correctly. It's just you enter in all the cases. Okay, so you don't have to, it tends to create fewer coding errors. So that's it, but it's nothing magical. It's nothing you can't do without ifs and elses. But, you know, if you want to update something like this, you're probably less likely to make a mistake in a switch block. Okay. So, a couple more slides. Well, let's go up. Here's the basic syntax again. Can't talk to you, bastards. Oh, jeez. This is not a good time. Okay. So again, in the switch, you're switching on some variable. You do case 1, right? Whatever the case is, and the value and a colon. You have statements that you want to execute for that case. And then typically you'll put a break after it so it doesn't continue onward. Okay, likewise, next value statements break. And if you want, at the end, you could put a default. So a default is for the case where you don't match any of the values. So that might be where you print some kind of error message, for example. You say, I expected to find one of these values. I didn't find one of these values. Somebody needs to know there's a problem. So key thing to remember with switch, cases specify the entry points into the block. They don't actually execute otherwise. And the breaks specify the exit points. That's all there is to it. There's only 2 rules, and they're pretty simple. Now, just like anything else with switches, you can do nesting. Okay, so for example, in our previous example, we covered the case of credits. So we might wish to distinguish someone who has 0 credits from a freshman who has more than 0 credits. So if we do this kind of switch, credits divided by 30, within our case 0 entry there, we have 2 options. We can say, first of all, if credits equals 0, right? If they actually have no credits, then we can assign new student to that string. Otherwise, they're just an ordinary freshman. So that might be something you could do. But you can nest ifs within switch blocks. You can nest switches within if blocks, whatever. Okay. Questions on switches? Questions on any of this stuff today? Nothing? We're all good? I hope, maybe. Oh, here's something. Nothing. Take a lot of time to process. Okay. Yep, well, Java does take a long time to learn to do it reasonably well. That's all right.
I had a question.
Sure.
Do cases have to be like specific values, or could it be like a range of values?
They have to be specific values.
Okay.
Yeah, so this is why it can be a little bit frustrating. But if you have a long list of exact matches, switches are good for that, right? But if you want to do something like, you know, a message for, same message for all values from 0 to 100, yeah, you'd need 100 extra cases for that. Unless, I don't think they've changed it, but it is worth checking because Java's periodically under development. They always do new stuff in there. So let's see what I can get. Let's find out. Because I remember one semester, like several years ago, where I said, oh yeah, you can only do switches on numbers, and the Java had just implemented the feature where you could do it on strings. And somebody's like, no, you can do it on strings. I was like, what? So you never know. They are changing this stuff. So let's see. Switch statement, a Java switch. Range of values. Yeah, so Java switch statement does not support ranges. Perhaps they will someday. But yeah, this is from, well, it's an old month, but yeah. All right, but it is good to periodically check up these things because Java's a big language and you never know, they might implement something like that in the syntax one day. But there's really not a reason to, because if you have ranges, you use ifs for that. Okay, good. Anything else? All right. So let's do, we got some practice exercises. I'm going to post them up. I got to dig them out from an old semester though. Unless I put them in. Did I put them in? Let's find out. No, I didn't. Okay. I have them. Where's my stuff? Where am I? All right, well, I'm just going to lift them from Blackboard from spring semester then. Okay, so one of these we already covered. This computer's kind of a problem. This is probably 201. No, it can't be. This is 201. Oh, this is weird. I wonder if I lost connection. There we go. That took a while. Okay. So here we go. I got this stuff from a prior semester. That's fine. I'll post it up later. What? Oh, it's not in course content. Not in that. Not in the lectures folder. Extras? No. Oh shit, I'm still in the fall. How the hell did that happen? I should have been in spring. Come on, guys. Get your shit together. La 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 la. We are waiting. Yeah, this is kind of silly, huh? Yeah, I thought I'd imported that stuff into our section, but I don't know what's happening here. Blackboard is, I lift it from fall. Let's see if I can access the fall ones. I have no idea what the problem is here. I'm gonna close out the slides. It's just not showing my stuff. How about you? Okay, good. There we got one. I get it from fall. All right. So course content, exam 1 content, lectures, characters, and no, that's an exam 2 for that one. It's in module 2. Every semester is a little different. Oh, okay, there we go. Conditional statements, practice problems. Let's see what's in here. This one we already did. Oh, good, good. This is the one I want. All right, so boom. So this is the first one. Let's go through it. So given the following code, what would be the value of Z? Okay, take a minute, go through it, and then we'll discuss it. I'll pause the recording briefly while we do this. Okay, let's take a look at it. So we'll do the walkthrough. So at this point, right, after these two statements, clearly x equals 0, y equals 5, right? Okay. After this, is this true? Is x at least 0? Yes. So x equals 0, y equals 1, right? We follow that. We'll try this. If x is greater than 0, no. So skip. X is 0, y remains 1, okay? We do the else. The if was skipped, so do the else, which means x equals 0, y equals 3. Down at the end, increment x, so x equals 1, y equals 3, thus z equals 1 plus 3 equals 4. Okay, so I can put all this in a new class in Java. Let's do conditional statements practice problems. Do that. Okay, so down here I'll have static void q1, static int q1. Do it this way. And then return z. Okay, so I'll do here system.out.println q1. Okay, we run that. And the correct answer is 4. Ha, how about that? Okay, next problem. There we go. Okay, so given the following code, what's the value of z here? Take a minute. I'm going to pause the recording and recording. Okay, let's take a look. I think people are on the right track. So after these two, right, x equals 1, y equals 4. After this, we add 2 to x, so x equals 3, y equals 4. After this, x is at least, if x is at least 3, y is 6. Yes, so x equals 3, y equals 6. Is y greater than 4? Yes. So x equals 5, y equals 6. Okay. If was true, so skip else, right? We don't do the else because that if was true. So z equals 5 plus 6 equals 11. Good. So a couple people typed in 11 there. That's great. Let's toss it into Eclipse. Make sure we didn't mess something up. So static and q2. Boom, drop all that in and return Z. And down here. Okay, and we can run it. And boom, we get 11. Very good. Okay, let's do one more. So this one, given the following code, what would be the value of Z? Okay, so take a minute. Once again, I will pause the recording. Oh, I guess I never did stop the recording. Well, all right. At any rate, let me, I'm taking a minute. I'll go back through that last one. Here's that code. It's in Eclipse now. Okay, I do a little walkthrough here, but that's all right. You can walk through yourself. Now we're on this one. Okay, any answers on this? All right, well, I'll do the walkthrough. That's okay. So at this point, right, we know when we go to the switch, N is 1, P is 3, right? Where do we enter the switch block? Enter here. Enter switch block here because N equals 1. I should say N equals 1. Okay, so at that point, what do we know? Well, we do this statement, so N equals 1, P equals 5, right? We add 2 to P. But continue. N equals 1, P equals 10. P equals P times 2. Down here, break, so exit switch block. And then down here, the value of P equals 10. So we can toss all this back into Eclipse. Make our last one. Static int Q4. Okay, I'll say return P. And up here, 4 and 4. Okay, so when we run it, boom, last one is 10. Okay. So I'm going to stop the recording, but if people have questions, happy to answer questions.